All right, here's the meat of the problem, number 3 on the Webassign. And on all these word problems, they're a bit tougher than if we are doing something real, actually, because someone's cooked the problem for you and they're asking you for specific questions. So this is not like real modeling. This is not how I feel when I do real modeling. It feels like I call it a textbook problem. But the whole thing is to get you familiar with the notation and what's going on. Here we go. So when we get a problem, a word problem, at least for a few more weeks, all of the recursion models or discrete dynamical systems have some missing information in them. All you're going to be doing is working with what we call a linear discrete dynamical system, which takes this form. There's a persistence rate, which in your book is always labeled A. There's they sometimes call this immigration rate, but you can think of it as that one disk that we kept adding if we had the dn minus disks moving in the towers of Hanoi. It's also called a non-homogeneous term. Sometimes it's called a forcing function, but whatever it's called, in the book, they always call it D. And the initial conditions usually left out too. So from the information you're given, you're supposed to try to get all that information down. And so the best bet, someone actually wrote this on one of the reviews that I got for one of the first papers that I wrote, is good theory comes from good examples. So go all the way back to Dr. Cottom's example and try to recast what you're looking at in terms of that. And go slow, don't try to rush. So here we go. Let's think about this. At noon on the first day of 2020, that's January 1st, you had a storage facility that contained 6,800 kilograms of radioactive material. How did I know to set my table up like this? Well, usually the time step is days, and whatever they're measuring is the Y value. So in the case of Dr. Cottom, he was looking at the number of patients coming back for follow-up visits. Here, we're looking at radioactive material. So that's the first thing, is to kind of lay out what your N is days, and what your P sub N is. It's the radioactive material on day N. Same thing. So I got my first piece of information on day 0. When we start, they had 6,800 kilograms of radioactive material. And now I do the same Dr. Cottom thing. They tell you that they're 6% less the next day. Well, if they're 6% next on day 1, I have to take 6,800 and subtract 6%. It's a little bit different than Dr. Cottom's because he wanted to retain 70% of his patients. Here, we're losing 6% at a time. I combined that on a calculator, and so I got 6392. On day 2, I'm going to get 6% less. And now you see it mimicking exactly what I did with Dr. Cottom as an example. I get 6% less, this thing. And then I go all the way up to N. In general, what am I doing to get from here to here each time? I'm always taking 6% less of the previous. So my DDS, my discrete dynamical system, or my recursion equation is P sub N is equal to P sub N minus 1, whatever I had before. If you go back to the previous step, you see whatever I had before minus 6% of whatever I had before. So whatever I had before minus 6% of whatever I had before. So now I'm ready to stick in everything. I don't have a question mark here anymore. I already know that P sub 0 is 6,800. I don't have an A and a D because it's not set up like that. But if you notice, 6% less is the same thing as retaining net 94%. If I'm 6% less, I'm really retaining 94%. If you don't like to think about it like that, you can also combine like terms. Think of the P sub N minus 1 as being an X. 1X minus 0.06X is 0.94X. So you can think of it like that. So now I know that my A is 0.94 and my D is 0. Now that I have that, I can answer any question that they want about this particular model. So the first thing they ask is, what's the A and the D? They don't say the A and the D, but they want me to fill in these coefficients. And my P sub 0 is 6,800. I fill that in. So I just grafted this stuff from the previous page. That shouldn't be kilogram there. I just pasted this. Then they asked me how much radioactive material will be in the storage facility. Well, I can just go to Excel. Here, instead of having clinical visits, we have dates. So you can modify your existing Excel file, but remember to save it under this particular example so that you have some saved files to look back on. So, but here instead of clinical visits, it's kicking up by dates. So my header changes to dates. And in there, I literally put 1/1/2020 in Excel, formatted it, and knew it was a date. The radioactive material on day 0 was 6,800, or January 1st was 6,800. I put it in there. My A was 0.94. That's the persistence rate. My D was 0. And then I do the same thing I've always done. If you already have this set up, as soon as you put the date in the first one, you could use the one you made for Dr. Cottam. So put in it should automatically make them all dates. If not, what you'll have to do is put the same A2 plus 1 equals A2 plus 1 in cell A3. And then over in the next cell here, you're going to have to, I don't think you're going to have to do anything. You can just keep it the same thing. It should automatically do it. C$2 plus times B2 plus D$2. The same thing we did on the day for the Towers of Hanoi. It's the same Excel sheet. So you can just take that Excel sheet that you made for the Towers of Hanoi and then modify it and then call this the radioactive material problem, whatever you want to save it as. So you have something with dates. That way it's easy for you to change it. And it's not hard to recreate it. It's just kind of, I told you I'm lazy. I don't want to do it again. And then if you have to recreate this, you highlight both of these rows, make your cursor a small cross and drag it down like we've done in class, all the way down to February 7th, and I get 689.032. They said round it to 3 decimals. So I can answer this question right here. The next one they ask is, what if you keep adding 204 kilograms? That's like the one disc that we kept adding in the Towers of Hanoi. So we just keep adding 204. So from somewhere, someone's squirting in 204 kilograms of radioactive material. That's D. So the hard part here, I think, is to recognize that you are actually, that this is D, that you're adding. And the reason that's hard is this is not a problem that you heard someone talk about and then you're creating it from that. You're having a cooked problem in writing that you're filling in parameters. So it's not quite the same thing as taking a real world problem and translating it. But once I understand that that's what they want, I just go into my Excel spreadsheet, change the D from 0 to 204, and the whole spreadsheet should change. And I can scroll down to the 7th of February, which happens to be my friend Joni Franzino's birthday. Joni Franzino is the voice on AM radio in the north, up here in the New York area. So she was my math buddy, but she went to radio and voiceovers. Just a side tidbit. 3,744.516. Punch that in. Now here they're asking you for the same thing. They're saying, okay, what happens if I change to 816? I'm a little confused here if they want it to be 816 more or 816. But let's assume that they mean here 816 daily. If you get the answer wrong, they mean 204 plus 816. I don't know. I'll double check that. But what you do is you go to your spreadsheet, change the D to 816, and then go down to the February 7th line, and you should see 12,910.968. So just playing around with the Excel spreadsheet. So once you have the model, once you have the Excel spreadsheet set up, this should be pretty rinky-dink. And then check with me about this 816, because I'm reading this and say, if instead starting January 26th, another 816, I took that to mean D is 816. All right, good luck. Questions, send them. Comments on the video of things you'd like to see, details you'd like to see, put it on the comment section of YouTube.